All right, chapter 7. We're doing 7.1 and 7.2 today. These will be the last topics for the midterm. So midterm will be next week, a week from today. We will go over a practice exam on Friday or Thursday. I will show you how to do everything. Okay. I'm not one of those teachers that teaches you says the test will be on these topics and then I just fucking gank you and give you some other bullshit. I think teachers that do that are assholes. Although I'd like to think I'm an asshole, I'm not that level of asshole. So the type of questions you see on the practice exam are the type of questions you can expect to see on the actual exam. No. That help? Does that help? There we go. Let's check the brightness too. Let's get that fucking shit out of the way. There we go. Bam. So chapter 7 is on normal probability distributions. And pretty much this is our go-to for the rest of the semester. Yeah, hold underneath the goddamn desk and everything. Just so you know where to find it, no need to look through your notes later on. Right smack dab at the top. StatCrunch is stats, calculators, normal. That's NSC. So the normal distribution model, this is the bell-shaped distribution. I could have one like that, or I could have, one that's lower. So I got two different ones. So it's got normal distribution is bell-shaped and symmetric. Symmetric about the mean. You. So that's fact 1. Fact 2. The area under the curve equals 1. Let's see. The graph never touches the x-axis. Or the flat line at the bottom. And it has inflection points at plus or minus 1 sigma. Inflection point is where the curve starts to change. And I'll show you pictorially what's going on. The larger the standard deviation, the flatter the graph is. This line, let's say this red one has like a standard deviation of 2. And we could say this black line has a standard deviation of 1. So the larger the standard deviation gets, the flatter that hill gets. Let me know when you guys are ready for more. Wait, I'm watching her, Linda. She's usually the. You're not the only one. Someone else is still ready. All right, I'm gonna leave that graph up there because I'm gonna draw in a second to kind of illustrate what I'm gonna say next. So for a given area under the curve, between 2 values. So I'm going to use like the red graph. I'm going to go up to the red line and just do like, I got a region right here. And I'm going to look at this area right here. The area under the curve. Oh, I already said that. For a given area under the curve between 2 values, we can say 2 different things. We can say A, it is the proportion of the population with the trait, whatever we happen to be talking about. The other thing it can represent is if we select a random person from the population. It's the probability that the person possesses the trait. So for the following example that I'm going to do on StatCrunch, about here, we're talking about the IQ test, this standard IQ test. The mean is 100. The standard deviation is 15. If we look at the range from 85 to 130. I didn't draw that very well. It should be a little bit more like that. This region right here to here. Following the empirical rule, that table that we had, this is 34%, this is 34%, and this is 13.5%. It's been a little while since we've used it. It should add up to 81.5% or 0.815. The empirical rule. This is an approximation. We're going to see what it actually is in a second on StatCrunch. So what this means is 81.5% of the population has a score between 85 and 130. And another way to look at it is there is an 81.5% chance that a randomly selected person has a IQ score and IQ score between 85 and 130. There's a couple ways of interpreting it. It's important to note, and you're going to see this in a second, this is a continuous distribution. In chapter 6, we were doing discrete probability. This is a continuous distribution. And while it may not make a lot of sense, if you have less than, it's identical to less than or equal to. And if you have greater than, it's identical to greater than or equal to. There is no strictly less than or strictly greater than. Well, the other way around, there is no equal portion. Let's see if we get 81.5% when we do StatCrunch. And give everyone a second to write all that stuff down. Everyone ready? Okay. We're gonna go stats, calculators, normal. The default setting is the standard normal distribution, which we'll talk about in a second. The IQ one that we're doing had a mean of 100 and a standard deviation of 15. And we wanted to look at the scores between 85 and 130. So I can click between. And I can say 85 to 130. And click compute. When I do, this gives me the actual percentage. So the actual score, and I know you can't see it, but I'm writing down what I see in this box right here. The value is 0.81859, which is about, I'll switch back to that in a second and we'll talk about the percentage. But it shows me the area in red. We can look at any particular score. If we do something like that, like the probability of being higher than 130 is relatively small. It looks like it's more than 2%, but that's only 2% of the area. To me, it looks more than 2%. Up here, it also has, see where it says the 68, the 95, the 99.7? That shows you the empirical value marks. So the empirical table has these marks on it. And so you can look at it with that in mind. That just changes the bottom row. It does not change any of the stuff here, but it changes the bottom row. You turn it on or off. I think having a non is more helpful because it shows you this is the mean. And as I go to the right, it shows me how the deviations are. Let's come back to the document camera. So the actual value we had was 81.859. If I rounded that and made a percentage out of it, I got like 81.86%. Which is not 81.5, right? But it's close. So the empirical table is not exact. Generally, from here on, now that you have access to know how to do the standard normal or the normal distribution, from here on, they will generally will tell you when to use the empirical model. The empirical table, the empirical rule, whatever the empirical something. You guys ready for more? All right. Get a piece of paper up. Quick distraction. On yesterday's class, for my half for another class, one of the students asked me if I had ever been scammed by a sugar daddy. And I said, what the fuck? He goes, sugar daddy, sugar mama, same thing. I said, no, it's not. Now, in my head, sugar daddy, sugar mama is not like the modern thing where you can just do the shit online. In my head, it is you're putting out for the income. So I asked him why it came up, and the student's like, apparently thinks they've been scammed or something like that. They changed their login and email or whatever they were looking at. How are you trying to get sugar daddies or mamas online? Apparently there's a website or some shit. So some doing it on social media. Her friend, she said her friend made 82,000 or so over the last 2 years, just from some guy in LA. He's got like 3 houses. He's hella rich. He's old as fuck. He's like 70. Just wants company. Yeah, it doesn't matter. They just fucking meet on FaceTime and he chats with her. I'm like, I'll fucking take a sugar mama, sugar daddy. All I gotta do is hang out with you for 40,000 a year. All right. But like that was I've never been asked that. It was fun. All right, back on task. That was your quick distraction from this shit. Let's look at an example. We're going to talk about the weight of giraffes. The weight of giraffes is normally distributed. This is pretty handy. Most problems will tell you if it's normally distributed or not. You don't have to assume it, they'll tell you. With a mean of 2,200 pounds. And a standard deviation of 200. So we're going to do 2 things. We're going to draw the empirical model of this. In fact, let's just do that right away before I mention the rest. So you make a nice little pretty bell graph. In the middle, we put the mean, which for us is 2,200 pounds. And then we go left or right, 3 deviations. -1 sigma, -2 sigma, -3 sigma, +1 sigma, +2 sigma, +3 sigma. And we figure out what those values are. As I go to the right, I'm just adding the standard deviation to the previous number. Standard deviation is 200. So as I go this direction, I'm adding 200 and I get 2,400. And as I keep going, I will just keep adding 200 at a time. Going the other way, we subtract. I'm only doing these arrows with the plus 200 and minus 200 just to make it clear what I'm doing. You really don't need to do that part when you draw it. And like, okay, we'll check out what this means in a second. But let's say we have, this is 2,500 right here. And the graph to the right of 2,500 is shaded. What does this mean? We had two things that we could say. It represents the proportion of the population, or represents the proportion of giraffes, since that's what we're talking about. And if we look at it, the numbers to the right of the 2,500 are all larger. And this is talking about weight. It represents the proportion of giraffes who weigh more than 2,500 pounds. The other option we could say it's the probability that a random giraffe weighs more than 2,500 pounds. Since it's off the screen, I'm going to rewrite what the mean and the standard deviation are on this graph. I mean, we could pull it from the graph, but we're going to look at this in StackCrunch. Give everyone a chance to finish writing. Brand is that?
It's fine.
Any good?
It's okay. My brother's obsessed with YouTube, and apparently it's Jake Paul and Kid Size.
Does anyone else know who Jake Paul is? I don't. Who is Jake Paul? What is he famous for? What does he do on YouTube that makes him famous? He what?
Like pranks sometimes.
So he's just an idiot on TV.
Yeah. And kids.
I bet he makes a fucking metric ton of money too if he's, this is some bullshit, the world we live in. What? All right. Let's go look up our giraffe. We said the mean is 2,200. Standard deviation is 200. And we wanted to see the probability that the weight was above 2,500. Notice you don't have a less than or a greater than. It's all just strictly less than or equal to or greater than or equal to. So it's 0.0668. I know you can't see what I'm writing, but I'll put it on the screen in a second. But I am writing what's in that last box. 0.0668. Again, remember we're doing stats, calculators, normal. You know what? I noticed, I'm looking at my two monitors. The monitor on the left is the one I'm working with. The monitor on the right is the one that shows on Zoom. The one on the left, for each box I have selected, it's kind of grayed out so I can see which one it is. I'm looking at this fucking screen though, and it doesn't show like a gray box over normal. Like the coloring is off on this fucking Zoom screen. I bet that's fucking up people at home.
I did Zoom last week, and like it was hard to see the numbers on a stat crunching we were doing. Like the answers of the gray boxes through Zoom.
Huh. Well, you can always do what we're doing. If you do that, you have to, like if you get sick, or if you're working from home, you can have StatCrunch open and do the same things that I'm doing. That way you can see on your computer what's happening. As an alternative. Let's come back and look at what that says here. That's the value we got. If we write it as a percentage, we shift the decimal right twice. We get 6.68%. So that's the percentage of the population that weighs more than 2,500, or the percentage chance that we will get a randomly selected giraffe to weigh that much. All right, so when you're trying to compare populations that are different, like if we're doing height, I don't want to say intelligence because men and women are equally intelligent. Height, men tend to be taller. So like comparing, the mean is higher for men and the standard deviation, I think is a little bit higher for men also for height than women. It's not a good comparison to just put them on the same graph and say what's going on. So we do something called the Z-score. So Z-scores, that's my Z. I put a crossbar on it and make it so it looks like definitely not a 2. Z-scores allow us to compare different populations or members of different populations. formula, it comes from this. It stems from the X value for like the bell curve. Any particular value X is equal to mu plus some multiplier on the standard deviation. So this is like how many standard deviations away from the mean. If we do a little bit of fancy solving to get z by itself. When I say fancy, I mean algebra. We subtract mu over to the other side, divide by sigma, and that's the formula for the z-score. He's recorded a dead body, that's why he's famous. Just a body lying there dead? That's all he did? Or did he kill the fucking person?
No, it's been hanging in a suicide board, trying to make fun of the body.
Wow, so he was an asshole that caught somebody, okay. Fantastic. The only reason I asked is because it reminded me, the bottle reminded me of like the Bang energy drinks, and it looks like the cotton candy energy drink. That one's fucking pretty tasty. I like the cotton candy Bang. I never even finished with the whole cotton candy thing when I asked, because you all told me it's some fucking famous YouTuber. All right, so formula for z-score is that. Let's look at it for our giraffes. What's going on with our giraffes? The giraffe in question at 2,500 pounds. That's my X. We had the mean was 2,200. And the standard deviation was 200. If I assemble my z-score from that information, I have 2,500 minus 2,200 over 200. If you're doing it on a calculator, you definitely need to do this top stuff first. This is 300 over 200. And then if you're doing it in a calculator, you can divide, or if you know, if you're comfortable with fractions, this becomes 1.5. So this giraffe is 1.5 deviations greater than the mean. All right, you guys ready for more? Oh, you're still right. Keep going. Let me rush you. Maybe a sugar mama. I'll give them my Zoom link so they can watch me work. Give them a shout out while I'm zooming.
I don't think you have to work anymore.
Be like, hey, baby. You know, some shit like that. What? I gotta get my wife doing this too. She's gotta bring home some bacon too. You don't gotta meet the person, just talk to them online. Sounds like fucking easy money. There ain't no sugar mamas like that. You ain't gonna find no 70-year-old woman that is so desperate for company, she's paying for it. She could find fucking company. For all the wide variety of ages. It's just that, oh, you get to be an old man, if you're not married at that point, it gets a lot harder. Unless you're like famous. Like that Jake douchebag will probably be able to get women when he's 70. No, he's gonna be inconsequential in probably 6 months. He'll be a nobody. He doesn't do anything. You only follow someone like that for so long before you're like, I'm bored. All right, so. Next topic. So this whole standard deviation thing, we've had a range of. Let me say standard normal deviation. Distribution. We've been doing normal distributions. We've been doing normal distributions, but the standard normal distribution. The standard normal distribution has a mean of 0 and a standard deviation of 1. It's quite literally the distribution for Z. Now, I hope I've gotten rid of these problems in the homework. I'm definitely not testing you on this, but if they're in the homework, the notation they like to use to check stuff is they will say, if you see something where it says like Z and a number like that, such as Z 1.2, what they're asking us to find is the probability that Z is less than 1.2. Then they have something called Z alpha. It's alpha. Looks kind of a little like the Jesus fish. Z alpha, and they'll say like Z alpha equals, I don't know, 2.2 or some value. Just giving examples with the 1.2 and the 2.2. This is saying to do the opposite direction. Z is greater than 2.2. I don't use that for the rest of the class, but if you see it in your normal day-to-day life, like if you're like, I like reading the Wall Street Journal and looking at stupid fucking statistic shit, and they reference it the alpha or something like that, that's what they're saying. So we still use stats, calculators, normal for Z-squared. So he recorded a dead body of someone that killed himself and he was making fun of it and it went on YouTube. And that person's family didn't kill him. Like I would, like if my brother committed suicide and some jackass fucking found him and fucking started heckling him, I'd hunt that motherfucker down and take care of some shit. He's at least lived a long night, getting his kneecaps fucking taken out. I don't know if I'm willing to go to murder, but he's fucking gonna be hurt. Someone like the person had to have had loved ones. Fuck that guy. He was famous before that? Okay. Wow, so a famous person, he just made it worse, more famous for that? Okay. All right, so let's just come up like this, some examples. I'll give you a list of examples to try. In fact, open up your computers in front of you for a second. If you've got your laptop, use it, if you'd like it. Otherwise, you can pull out the computer. In fact, it's good practice, knowing how to use this shit. We're gonna look up, I'll have you calculate scores in the calculator. Let's find the probability Z is greater than. Let's do the 1.2. I said less than 1.2 a second ago. Let's do probability that Z is less than negative 0.4. I know it's gonna take you a while to log in. You gotta log in with your student information if you're using the school computer. Like the way you log into Canvas, that same information will get you in to the computer. And then log into MATLAB with you, whatever your password is. Let's say greater than negative 0. Oop, I didn't change the symbol. Infamous is a better word. It sounds like he's a douchebag. So famous is a positive thing. Infamous is for douchebags. I thought a fool up. He makes up kind of good. Tommy, you're missing it. Blowing bubbles up here. After you guys do this, we're gonna do like 3 or 4 word examples. I mean, what we've done. This chapter 7 is not a long section. So I'll give you a little while to get logged in and calculate these. And remember, you're doing stats, calculators, normal. There's at least 1 or 2 problems on the midterm that has this. So like, that's why I'm like making sure you know how to do it.
And that kind of, right?
Yeah, StatCrunch. So he became a pro boxer after he got canceled. Huh. So people were bored with him already, so he became a professional boxer. Interesting. He liked the spotlight. Didn't want to give it up. Want me some fucking cotton candy banging now. Most energy drinks taste like shit to me. Like the cotton candy one is like, this is tasty.
I like I think it's black cherry vanilla. Right?
I'll have to try that.
And if you go to Winco, instead of paying like $3.50 at a gas station, they're like,
Oh, yeah, really cheap at Winco.
they're like $1.
It's Girl Scout cookie season. They have a delicious one called Adventure Fills. They've got chocolate and peanut butter and it's not like the chocolate peanut butter patty. It's got like a cookie and it's fucking, oh my God, they're so fucking good. Hey, Matt, if the students wanted to have a potluck during the midterm, how could I do that for the stats room? Is it doable or am I gonna get in trouble? Question mark. For my Zoom users at home, you could try doing the same thing. Make sure you're logging to StatCrunch and try to see what you get. We'll do them together in like 5 minutes. You fucking haircut. Go over them together in one more minute. All right. So we'll start from scratch. We'll go stats, calculators, and normal. The default setting for the stats calculator normal is standard, the standard normal distribution. So I'm just going to leave the mean and standard deviation alone, and I'm going to start plugging in the values we wanted. If it doesn't have the option of changing the x to a z, but we'll just pretend it's a z. The first one was z is greater than 1.2. And if I write it in, I've got 0.11507. I go to decimal places. Next one was z is less than negative 0.4. If I go to 5 decimal places on this, I've got 3, 4, 4, 5, and then I round to the last spot is an 8. If I want to do greater than, I just change the sign. That makes it easy. This line was 0.65542. The last two had between, so we'll click on between. And we start off with -1 to 2. We actually saw this a second ago. This was my IQ example. 81859. And if I do -2 to +2, I get 0.95 44 or 450 if I round to the 5th decimal place. So you're just going through and editing those, putting those in. And you should have gotten those values. We said that this could represent probability. Probability has to add up to 1 for 2 different things. Notice how on this one I had less than -0.4 and greater than -0.4. This covers all possible values of z. So the probability of Z altogether there should equal 1. Which means if I add those up, I should get 1. Which is an interesting thing. When we did the empirical model for 2 deviations, we got 95%. So again, the empirical model, not exact. Your general rule of thumb if the Z values are integers, are whole numbers basically, use the empirical model. Otherwise, calculate it. Calculate probability. Is ready for some more? Yeah. Let's do some examples. You manufacture gizmos. That's what they're called, gizmos. You don't want to sell defective items. So you decide to scrap the lowest and highest 10%. Find the Z-score cutoffs. I'll write down another question that we'll also do. In StatCrunch, right after this. GRE scores represent percentiles. The Z-score for the 88th percentile. And percentile, as a reminder, are values below that. What you write down, I'll give you a little bit to write down. Then we'll shift over to the other screen. Before computers, Z-score used to be the way you had to do these calculations. There was a giant table to like four decimal places for your Z-score. You found out where your Z-score was on it, and you read the value from this massive table. It sucks ass really bad. It's not fun to teach. It's not fun to use. Every grade once in a while, I get a student that wants to fucking use it. If you are one that wants to use the Z-score table, knock yourself out. I am not teaching it. If you ever do statistics in the real world, your boss is not going to want you to use it. So, is that a thumbs up that you want to use it, or a thumbs up, fuck no, I ain't using it? Okay. All right, let's take a look at this. So we're doing we're going to leave it at standard deviation because we're looking at, or standard normal because we're looking at Z-scores. And the first one said scrap the lowest and highest 10%. So if I don't know what those values are, I can come over here and actually put in 0.1 is the equivalent of 10%. The box on the right represents your percentage in decimal form. So if I make that say 0.10 or 0.1, I am looking for what is in the top 10%. If I click compute, it shows me that these values to the right of here are in the 10% that direction, and it gives me the Z-score right there. So the Z-score, the higher one is positive 1.28155. We'll stop there. That's 5 decimal places. So in this problem, we're not editing the Z-score part, we're editing the percentage box. So if they give you a target percentage and they want you to find the Z-score, that's what you change. You put in the information you know. So I'll write this down right here as I'm saying it. Plug in the percentage you know you want as a decimal in the, for lack of a better word, the answer box. And see what Z-score you get. We're going to do this for the GRE thing as well. I'll switch back to that in a second. If I want to see the bottom 10%, I'm gonna get rid of that Z-score. And I'm gonna make this say less than. And notice I get the same value, but with a negative sign. I get negative 1.28155. This is because the normal distribution is symmetric. So 10% on one side is 10% on the other. If I want to do the GRE score, I want values that are less than, I'm going to get rid of that. But I'm going to say less than 88%, which would be 0.88 right there. I'll click compute and it will tell me the value right there. So I'm going to write that value down and I actually kind of depict the box right here. Let's say we've got mean. Standard deviation is 1. We got a box there is 1. I'm doing probability that X is less than, and I'm going to leave this block blank. Equals. And I'm putting in my 0.88 here. Click compute, and it spits out the answer that goes in there. The answer that goes in there is 1.175. The 3 decimal places. So the Z-score is 1.175. I actually think I have examples like those two on the practice midterm, so there's no point in doing them right now. So that kind of covers today's lecture. Which means you are allowed, you can work on homework, or you can go home, or you can call your sugar daddy. Whatever you want to do.
I actually have a friend that my mom called. I told her I'm really sending money for like food and gas.
It's all right, you know, put the fuck can down, put your shit down. We're digging into this a little bit more. Do you talk to the guy?
No, I'm like a relation. Friends.
Just friends, and he just helps you. So okay, so it's just a friend. That is it like an older friend, like an old, like your mom's age friend?
No, he's 20.
So he's a sugar.
That boy wants to get with you. That ain't friends. That's a guy that's in the friend zone and don't want to be in the friend zone.
He knows he's staying there.
No, no, you do not understand. Let me turn off Zoom for this. You do not understand the level of delusion that guys will do